Okay, so we're looking at the voltmeter, what the voltmeter reads when the switches are in various configurations, all of them open, any one of them closed, and all of them closed. They have various situations outlined over here. Did you do it? What happens? So I just went ahead and set this up on the PhET simulator. So hopefully you did it and you checked your answer on the PhET simulator. I made all the resistors 2 ohms. And I made the battery 10 volts, just to make it easy. So let's look at what happens when they're all open. When they're all open, let's start with switch 3. When this is open, this resistor is basically removed from the circuit, right? We have an open circuit here, an open branch. Nothing flows through that branch. If we could just remove that. Nothing flows through where S2 is. So the current comes out of the positive side of the battery through these 2 resistors. It can't get through this branch, and then through these 2 resistors. So we have 4 resistors in series. What is that? 8 ohms, a 10-volt battery, 1 1/4. Is that right? Current would be 1.25 amps. And so the voltmeter would read V equals IR. And if that's a 2 ohm resistor, it would read 2.5 volts. Is that right? So here's my circuit. Oops. There it is on the PhET simulator. All 3 switches are open. You can see the path of the electrons here. Current would be flowing the opposite direction. These are the electrons moving. But you can see the path it's taking. Nothing goes through the open branches. And we're getting 2.5 volts on that resistor right there. And then you can just start going through the various scenarios here. If you close, let's do switch 2. This one. If we close this switch, what's going to happen? All the current will take that path, right? Because that's a 0 resistance path. That is a short across these 2 resistors. So when the current gets here, remember, as long as there's some resistance in every parallel path, some current takes every path. But if you put a 0 resistance path, all the current takes the 0 resistance path. So that's what this is. This is a 0 resistance path. So no current will go through those resistors. Let's see what happens. So that means we've removed those. So we only have 2 resistors now in our circuit. So it should be twice as much current, which means twice as much voltage there. So let's close that switch. So you can see the current no longer takes the path that has resistance because there's a zero resistance option for it now. So it only sees 2 resistors, and you can figure out what the current is and what the voltage would be. Twice as much as what we had before. Okay? And you can go and change these switches, and as long as switch 2 is closed, it doesn't really matter what this switch is, right? Because nothing's going to go through this resistor if there's a 0 resistance path there. And then if we close the other switch, then that puts 2 resistors in parallel, which reduces that resistance from 2 ohms down to 1 ohm, right? The equivalent of 1 ohm. So what would that be? That would be 3 ohms total, right? A 2 ohm resistor, and these 2 in parallel are equivalent to 1 ohm. So the circuit has an equivalent resistance of 3 ohms if I close this resistor over here. 3 ohms and 10 volts, what is that? 3.3 amps. So this would read 6.6 volts on that one resistor. Is that right? Let's see what happens. Come on. There's a little delay there. Did you follow that? Okay. So you can play with it some more yourself. Open and close the switches. Check all the various combinations. See if you get it right. Good? All right, turn that sheet over. Maybe the more interesting side is over here. So check with your partners there at your table. Talk over the first one. And then we'll, while you're doing that, I'm going to set it up on the PhET simulator. And then we'll check our answers.